take 16 on this video, and I'm not even joking. So let's hope this is the 16th time this is charm. So I know a lot of people were struggling with quantum numbers, so I did want to go over it really quick. Essentially, there are four principal quantum numbers: n, l, m sub l, and m sub s. And these stand for size, shape, orientation, and spin, and describe the electrons, specifically of the valence electron, which is that last electron we care about. So for instance, looking at the periodic table, we're going to look at carbon. And again, in the P block, this is the second electron we care about. That's the one we're going to focus on. Vanadium is the third one in the 3D, and sodium's in the 3s, in the first spot, specifically what we care about. So let's just jump right in. So the size is referring to, again, the large number here. And you can see I color-coded that red. That instantly tells you that this is going to be the third of the S's, which can be big. So imagine this is maybe a 1S, a 2S, which is bigger, as you can see, and then a 3S might be something even bigger than that. So like 1S, 2S, and 3S. So that number comes from strictly the first number that we care about, specifically at the end. This is completely about that last bit, the last electron. And I just caught a little mistake there. Someone fix that for everyone. So the shape. The shapes are kind of like a code, and that refers to the S, P, D, and F. Again, sphere, peanut, P for like the clovers, and then F is a little funky. The code is literally 0 to 3. So looking at this, I know that I have the 3s1 electron. My size is 3 because of this. S's code is 0, so that's L. And now let's talk about M sub L and M sub S. There is only one electron here, and that's specifically because of the 1 I'm seeing here. Well, here, there's only a 0, so it's 0, because again, the orientation is going to be the negative L to L value. So here it's negative 1 to 1. There's 3 numbers here, right? There's 3 orbitals. There's 5 numbers here. There's 5 values. So it lines up. So here, there's only one electron in that spot. It's 0. Because it's going up, our spin is positive 1/2. I know the online stuff didn't really talk about M sub S, but I wanted to throw it out there in case you see it. It's literally, is it spinning in a, what they call positive direction, or what they call a negative direction? Because again, if you have opposite spins, you can repel from one another. If you're doing it the same spin, you're not really repelling. You're staying kind of close. You want to get back away. You have electrons hit each other. So those are the quantum numbers. For this case, we're talking about the 2 p2 orbital. That's the last electron, specifically with carbon, and is 2. P's code is 1. We care about the second electron. So that's this one specifically. That's in the 0 spot. And it's going up, so it's positive 1/2. This really isn't that bad, right? It just takes a little bit of getting used to. N is 3 for vanadium, because there's a 3. The d orbital's code is 2. Again, this is literally just like a code for it. I'm in the 3rd spot. That ends up being 0. And again, it's still going up, so it's positive 1/2. If you were doing, an element maybe like zinc has a -1, chlorine, sulfur, some of those have it, but that's really how you can get those codes. Again, check those out. Let me know if you need anything, and later.